In this video, we're going to test the Active Aero computer from a 1990 Mitsubishi 3000 GT. So this is the same as a similar age vehicle, Dodge Stealth or Mitsubishi GTO. So over here we've got the Active Aero computer that's removed from the casing from the car. Here's the Active Aero switch that sits in the dashboard center console to control the Active Aero. And then over here we've got our special test rig, which has some micro switches here to simulate the limit switches in the spoilers, and some LEDs that show us the motor drive to both the front and rear spoiler. So the Active Aero's current switch is currently in its middle position, power is off. Now we've set this up so that these micro switches are going to be the opposite way to which the computer is going to expect to see them when it's powered up, i.e. the spoilers are in deployed position. So the first thing this computer is going to do is it's going to tell us to, it's going to tell the motors rather to move the spoilers to their parked or non-deployed position. So if I power it on, you'll see these LEDs come on, and I've only got 2 or 3 seconds to move these switches to simulate the movement of the spoiler. So if we switch that on, you can see the LEDs here, and I need to simulate by moving these switches like so. And now the computer thinks that the spoiler is now in the retracted position and the LEDs are off. There's actually a warning LED just here which mimics the one on the dashboard. It's off, which tells us that the computer is happy. Now, if we then increase the speed signal that goes into the computer by powering the frequency generator on, and then we turn this guy up to simulate over 50 miles an hour, you can see it's now trying to move the other direction. So again, we push these back and we tell the computer that the spoiler is now in the deployed position. And a frequency generator is simulating a speed of around about 60 miles per hour, which is the speed at which the spoiler deploys. Now if we go the other way and we turn the frequency generator down and we get below equivalent of 40 miles per hour, we will see that it goes the other direction. And this is telling the computer to essentially retract the spoiler. And there we are in the retracted position. Now if we repeat and go back up to deployed again, here. Okay, so again we move the switches into what will be the deployed position like so. Then we can see, if you can see that on the camera, there's a green LED there, look, which marks which tells us the Active Aero spoilers are actually deployed. And then of course we can turn the unit off from here as well, like this, and then immediately the system starts to retract the spoilers, and again we can move the switches to simulate that. Now the system's quite happy because it thinks the system is the spoilers are retracted. So this gives us a pretty thorough test of this unit, including the speed activations, you can see, and enables us to be confident that this Active Aero computer is actually working fine. And we build these type of test rigs for every module or unit that we test to give us confidence that when we've repaired a unit that we know it's working and it's going to be stable in use.